Welcome to the presentation of the paper Affinity for Technology and Teenagers' Learning Intention. The paper is co-authored by Fufen and myself, Monica Divitini. We are both from the Norwegian University of Science and Technology in Trondheim, Norway, that you see in my background. In this presentation, we will provide you with a quick overview of our background and research question, the theoretical background that is in the expectancy-value theory, our hypothesis, our studies, the result, and some of the implication. Of course, due to time limitation, this is only an overview, and for detail, please check our paper or contact us. So what is the motivation behind our work? In the last years, we have seen a growing interest in activities that tend to promote computer science education, engaging and motivating students. Often we see that these are one-off activities. So students are engaged during the activity, they enjoy it, but they are not interested in pursuing this line of study. So our main research question is what determines teenagers' continuous learning intention?
Looking for an answer to this question, we turn to the expectancy-value theory and the construct of affinity for technology. The expectancy-value theory was developed by Eccles and colleagues. According to this theory, persistence and task choice were determined by two factors. One is beliefs on ability, and the other is task value. The task value has many components, including interest and intrinsic value, IV, and utility value, UV. IV is the level of enjoyment an individual derives from performing an activity, and UV is the degree of usefulness a specific task has for an individual. And based on the expectancy value model, we have identified affinity for technology as an important component of beliefs on ability. Affinity for technology refers to the attitude people hold for general technology, including the beliefs in competence in using and learning new technologies. So based on the expectancy value theory, it can be argued that affinity for technology has a significant impact on students' learning intentions. So it suggests for the first hypothesis here, that is, there is a linear relationship between affinity for technology and learning intention. In other words, higher affinity for technology leads to higher learning intentions. Our second hypothesis concerns the mechanism linking affinity for technology and learning intention. Particularly, we hypothesize that perceived usefulness and enjoyment mediate the relationship between affinity for technology and learning intentions. And our in the third hypothesis, we are interested in whether gender and school type moderate the relationship of the interest. This represents either moderated mediation model.
To verify this hypothesis, we have set up a study involving 108 students divided in 4 classes in lower and upper secondary school. The students were all born between 2004 and 2006, and we had a good distribution of boys and girls. So a full description of the learning activity is beyond the scope of this paper. Here we just want to briefly mention that the activity was intended to introduce students to IoT, Internet of Things, without requiring any previous knowledge in microprocessor, in the concept of IoT, or even in programming. The activity was promoting collaboration, creative and design thinking, and creativity. The activity was planned for a total of 10 hours that were distributed in differently depending on the schedule of the school. The, the activity included a hands-on design workshop without any programming involved, as it is represented in phase one, a hands-on tutorial on the specific microprocessor that we were using, as illustrated in phase two, and finally, in phase three, the development of an interactive object, in this case, a smart interactive recycling bin.
Here are the measures of use in the study. First, affinity for technology was measured by 8 items. And one exemplar item is I enjoy learning new software applications and hearing about new technologies. Perceived usefulness was measured by 3 items. An example is the activity improves my performance on science and technologies. Next, enjoyment was measured by 6 items. One exemplar item is attending the activity was enjoyable. And finally, intention to attend similar activities was measured by 4 items. And the example given here is I intend to attend the activity in the future. Results from linear regression indicated that affinity for technology positively predicted continuous learning intentions. Standardized slope beta equals 0.403, which is significantly different from 0. In addition, affinity for technology explained over 16% of the variance in learning intentions. So this means higher affinity for technology leads to greater continuous learning intentions. And our first hypothesis was supported. From mediation analysis, we find that affinity for technology is mediated by usefulness, but not enjoyment. From the indirect effect, we see that the indirect effect of usefulness, for indirect effect of usefulness, the 95% confidence interval did not include 0, indicating that usefulness is a significant mediator. On the other hand, for the indirect effect of enjoyment, the 95% interval did include 0. This means that usefulness is not a significant mediator for the relationship between affinity for technology and intention. So our second hypothesis was partially supported. So this, as you can see from the figure here, affinity for technology leads to higher perceived usefulness, which in turn leads to higher learning intentions. From moderated mediation analysis, we find that all the p-values were greater than 0.05, indicating that no moderation for gender of either gender or school type on any of the pathways. So our hypothesis, our third hypothesis, which is affinity for technology exerts its effect on learning intentions indirectly through subjective task values dependent on gender and school type, was not supported.
Okay, so summarizing the result, we can say that learning intention are in part the result of a general individual difference in affinity for technology. And what is maybe our most important result is that this is mediated by perceived usefulness, but not perceived enjoyment of the activities. Also, affinity for technology exerts its effect on learning intention indirectly through perceived usefulness independent of gender and age. So, given our result, we think that when designing or implementing learning activities in a formal or informal setting, is it important to consider that enjoyment and engagement are important, yes, but cannot alone assure the intention to learn and follow the pattern ahead for student. It is therefore important to scaffold the participation of students, taking into account their attitude towards technology, matching their strengths and needs. In addition, we think that given the importance of usefulness in mediating the intention to learn, the usefulness of the activity should be made clear by the teacher, for example, in terms of path forwards or how it connects with other aspects of STEM education. Of course, this is not the final answer to a very complex problem. We think that we need to do more research to identify how cultural differences may impact on the result. And we also need to extend the concept of usefulness. In our studies, we have mainly related it to effectiveness in the context of STEM education. Um, what about, for example, usefulness at the societal of an activity at the societal level and so on. So this concept of usefulness need to be extended and adequate research tools to measure it needs to be developed. So we here conclude our presentation, thanking you for your attention, and please drop us an email if you have any question.